for that, in order for you to eventually trust them. Today, I think that's kind of missing, and I think trust in a lot of the things that we've been trusting is kind of eroding. How many people actually read the terms of use when Apple pops up and says, oh, sorry, you can't do anything else until you agree to these terms of use? How many people actually read those? Okay, there you go. I printed the terms of use one time. This was been at least 5 or 6 years ago. It was like 30 pages of 9-point type. Okay, I printed it, I didn't read it. Again, policy, one of my slogans is policy is the last frontier, okay? As computer scientists and networking people, we like to focus on performance because it's easy to measure and it's easy for a long time it's been important. I'm not sure it's the most important thing today. I think security and privacy are arguably at least as important as that, but they're much harder to quantify and measure and run an experiment and say, look, I did better than that other paper did. We cannot have one size fits all, which is what we basically have today. On the other hand, we can't rebuild everything from scratch for every application and every user. So we've got to have a small number of sizes that fit almost everything, and then a little bit of customizability. But, you know, I think there's some good news. I think NDN and ICN more generally, all of the information-centric networking approaches that I've seen build a security component into the network, and that is completely consistent with the end-to-end argument, as long as whether you want to take advantage of that, whether you want to pay the price in terms of performance or whatever, is a policy decision. And I think with NDN that is completely the case, because if you want to verify signatures, you can. If you don't want to verify signatures, if you don't want to even sign, you can put garbage in the signature field if you know that nobody's going to verify it, right? I think it also opens up an opportunity, a business opportunity for providers to do that extra work, to offload that verification cost into the network for an additional fee. Okay, so there's an incentive. There's a way to align the incentives to have the trust work out. And then you've heard this morning, I think, excellent work on using the namespace as a building block, and you can encode policies as patterns on names, and then you can pass those around, including, for example, giving them to the network and saying, please enforce this policy for me about who's signing my data. You can build confidentiality on top of that using namespace conventions, as we heard about this morning. But then that results in a lot of complexity, and so we have to figure out, as I think the NDN folks are doing, how to hide that from the user and how to automate as much of it as possible.
Right, so I just have a couple of comments. So with respect to our discussion, so basically, when we started looking at cloud computing, we were trying to push everything to the cloud. When we started talking about IoT, we were trying to bring it back. And as a result of that, there were a lot of issues that came up, specifically from the perspective of the number of devices that we have and the amount of data that we have. So I was reading a paper recently when I was preparing for the panel, and it was talking about the amount of data that could be generated out of a Boeing aircraft within a second, and they were talking about something close to 5 gigabit per second. And you can imagine the same thing within vehicles as well, as we're going into the notion of vehicle-to-vehicle communication. So a lot of traffic being generated, and at the same time, some of these environments don't necessarily have a lot of bandwidth that they could use to be able to communicate or send that information out into the cloud for processing. So the notion of trying to bring some of that processing back into the edge made sense. So if we try to look at why we wanted to do this, we don't have a lot of bandwidth. And a lot of times we have contested environments where network disruptions are pretty common. There's also some requirements on delay, which translates to applications that may necessarily want real-time processing. and also, from a user experience perspective, you want to be able to improve the user experience by minimizing delay. So that's what brought us to this notion of edge computing. So anytime I hear low latency, reducing bandwidth, I don't have links that have a lot of data, and I have data that, in a sense, could be used by multi-points or multi-party communication model. NDN pops to my mind because it's got very, very good characteristics that enables you to be able to operate in this environment. Talking about some of the caching functionalities, the power of names, and the services that you can introduce to the network by leveraging names, and also the security functionality, the fact that you can sign data, the fact that you can encrypt data, and also there are a lot of other services that you can introduce that leverage names. So, for example, I've always been thinking about this notion of the equivalent of a firewall based on names. You could do that to be able to segment portions of your network, to be able to provide some of the privacy requirements that these environments may require, so that you can only pass data to certain components within the network that need it, and then block it otherwise. So in a sense, NDN and the fact that you have security built in, the fact that you can use your communication resources efficiently, and the fact that you can provide use names to provide some services that operate on the data directly as opposed to the communication endpoints. It seems like a very good idea for the use in this environment.
So I agree with many of the great points that other panelists made. I just want to kind of a little bit augment what has been said. I think one important characteristics of NDN or kind of the future environment is not necessarily being connected to whatever centralized environment or being connected at all. Like there are many devices, many thousands of IoT devices on the car, maybe just connected within the car and never leave anything. And we have to provide the communication, processing, and communication, storage, and processing capabilities even within that small environment. And in the end, by utilizing names, kind of application names at kind of different layers, effectively at application, at the networking, at the transport, you can actually meaningfully use communication and storage and processing capabilities at any points of the infrastructure. So it's kind of, network will define by whatever routing policies where the request to process specific pieces of data will go, and if it's deployed at that point of time, at that point of place, it will be processed. If it's deployed at a different point, then it will be processed there. And as was emphasized, the security is part of the kind of communication part itself. The questions that we'll probably be discussing that Jay put, those not necessarily answered by NDN, but rather it's more like a policy question. And if we decide on a solution, we'll probably be able to realize it with NDN way easier, way better than it's possible to do with any other technologies that may exist. But the point I was kind of trying to add in addition to what I was saying, the processing capabilities. So I kind of already mentioned it, but I think Tamer used the services as part of the conversation. But those were mostly, I think, kind of firewall services like, but the processing can be done, like the actual processing, kind of Lambda function, like Amazon Lambda processing style, like somewhere in the network itself. Yes, we need to figure out the trust relationship with that entity. Yes, we also need to figure out the incentive of that guy to doing that. But we had like one paper, one idea was not for the processing, but for the storage, is that the service provider, in addition, kind of like wireless service provider, in addition to giving you just simple access to the internet, it also giving you the storage that goes with you whenever you go to some different place. And that's kind of with NDN to realize that thing, kind of just piece of cake. If you want to do something like that with IP, then it's getting a bit hazy.
Okay, thank you very much for your comments. Let's open the floor for questions.
Christian Schudin, University of Basel. The impression I had from the presentations right now is that all your views are ahistoric. So you take the data as it is, the network has to ship it as it is, and there's some trust relationship somehow. But the provenance of the data and how you deal with trust when it is broken might be the more important part. The trust will be broken at some time, but then you want to go back in time and see who broke it, when. If you have enough traces, that's fine. So the namespace by itself does not give a solution. The trust by itself will not give a solution. You would have to impose a secure chaining of the data and really think about how the data is generated from the beginning of an experiment to the 10-year long-term archiving of that, and you want to see what lambda function did apply and what result is generated, what did the network then transport. So it's much a bigger problem that you can't solve at NDN and edge level. That is what I wanted to point out. Is that view right, that nobody of you has taken history into account, how the data came to existence?
So I think that's a good point. If I think about that, I end up with it's just turtles all the way down, because you got the same problem with the history, right? You don't want to have to go back to the beginning of time every time you ask a question. So you're going to have to summarize it and take a snapshot or something. And there's going to be some trust involved in creating that thing, right? So I agree with you about the provenance, and the flip answer is, of course, we'll put every single thing that happens in the blockchain, and that'll solve the problem.
And that solves the problem. That's actually, in my opinion, this is an important question to be answered in terms of how do you. So, and I'm not a panelist, I'm just a moderator, so I'll let everybody ask questions and answer. But that's something that we have been trying to look at, even when you're generating data at the edge. You know, I move the data to, at the edge, and then I move the data to the edge node. And the data gets stored there forever. So should I use my certificate for it? Should the infrastructure use their certificate for it? Somebody else in the cloud should use their certificate to sign it, and then how does it tie back to me? These are questions that really, and that kind of goes back to your history question. So if I, 10 years down the lane, my son wants to look at the data, does he trust that his father's phone generated it, or who generated it? So those questions ought to be answered, and people are looking at it in different ways. But
I may actually understand this question slightly differently, and I don't have an answer. But I have maybe bigger problem is, let's say there's an edge device, like the processing box somewhere, and it may produce the good results for one of the types of the requests, the bad results for the other types of requests, well, not types, but just different data sets. And how we distinguish, how we figure out that box is lying to some part of the processing. So these are kind of related to the historical question, but even bigger problems, like how you trust the processing, and that the guy actually did the processing and did the faithful one.
So I think this is going to get more important, right? Which may ultimately lead to some kind of standards or regulatory solution, because recently there have been a number of demonstrations of, for example, forged video where you can make it look like somebody's saying something that they never said, and it's really, even experts have a hard time distinguishing it. So this question of provenance, and you can imagine some kind of standards for verifying that after the fact.
Hi, Carrie McKay, NIST. I'm actually a cryptographer, and I'm new to NDN. So I've been talking to Rafaei and his group about some of the proposals that people have put out there. And one of the problems that I keep having when trying to analyze these is I don't really understand what protocols are trying to achieve, what particular properties that they need. And also a lot of the algorithms I'm looking at are maybe published in some kind of transactions or something, but it's not in a form that I can actually wrap my head around or like play with or anything like that. But right now my question to you is there a unifying like security model or threat models for NDN? And if so, can you shed some light on what they are? Or is it something that's application specific? So maybe if the airline had an NDN versus my home had an NDN, would those two have different goals?
Again, I wouldn't have the exact answer, or maybe even remote answer. For me, I don't think there is a unified model. Like NDN is a general networking architecture that can be used and should be used in completely different environments, like IoT environment, vehicle environment, satellite, whatever, universe, global networking environment. And security requirements could be similar, like have some similarity that trustworthiness of the data, but not necessarily the same. Like some data doesn't have to be completely confidential. For some data, you only want to content confidential, but not metadata. For some data, you want to be everything confidential multiple times. So kind of non-answer to this one, to this question would be, I don't think there's a unified model.
I think that's a great question. And given not being a security person, I don't think I'm qualified to answer it. But I do remember there was such a talk that's, I think, relevant to your question that was given by Alex Haldeman 2 years back, like I referred to this morning.
Yeah, I've actually seen it.
Right. So he actually pointed out that, generally speaking, if I remember right, he said that security people start a design by first identifying a set of threats. Mm-hmm. And the NDN design actually started from a different angle. Because he mentioned that threats, we can do our best to do this. We actually don't get to control or decide. What we can do is we design solutions, architectures, mechanisms. So therefore, he sees that NDN really started from the design model to say that what we can build in as a security building block that can be used to provide solutions towards the different threats, anticipated or even not anticipated. Yeah, so there's no unified threat model. Basically, that's my answer. But I also pointed out, like a security person argued to say, looking at the whole direction from a very different angle, that's actually very refreshing and seems to offer great potential.
I don't think there's a unified model. I think we start to build these as we apply NDN to different environments. In my mind, at least, when I'm thinking about TCP/IP, I think the threat model is still being developed today. I don't think we have a full threat model for TCP/IP, so this is something that we build as we go on. And there's things that we learn as we look at the NDN architecture. When we start to apply it in different environments, we start realizing, for that particular environment, this particular piece has an issue, right, from a privacy perspective. And to give you an example, in one of the contexts where we're trying to apply NDN, surprisingly, or maybe not, but it depends on how you guys take it, but names become a problem because names expose information about what the data is. And so in that case, the threat model has evolved from just protecting the data to looking at what information can I learn from the name, how can I protect that. So these things happen as we try to apply it to different environments.
Earlier, I tried to actually mention another thing. I think Ken brought up very good questions that really deserve further discussion. This morning, he brought up the question about what's the ecosystem for this augmented reality browser. And just now, he asked two questions I thought was really interesting. One is about if the data is read-only, then you can have end-to-end security. What if the data get processed in the middle? How do you handle that? So I'm just bringing up this for discussion. Exactly for this thing, it just happened. Christian and I had a series of interesting exchanges. So one way to see it is the following. From his viewpoint, he said NDN network is a worm. WORM. Write once, read multiple times. And I think that matches to what I said this morning, right? The producer sign, the consumer verify. So data is immutable. Once it's out, it is out. For the middle processing units, they are merely new producers. So therefore, if you view this, the end-to-end is from producer to consumer. And everything is read-only. It is read-only, right? So there's no modification in the NDN model to the data.
Can I add maybe to what you just said? It's probably just augmenting the concept of how to trust the guy in the middle. So maybe the direction that we could go is when the consumer, whatever, who wants the data being produced, who wants processing, not just specifying that it wants processing on this data or like with this function, but also providing a function itself. Like if it trusts its own code that it's written, and there is some kind of certified process that trusting the actual compute is instructions, then by providing the code, you may have a meaningful trust in what's being processed, not by you, but in some other remote case. But again, it still has a kind of open issues, and the consumers or requesters still need to do verification and ensure like random types of verification to ensure that the guy is doing the job it's actually promised to do.
You know, maybe another approach is to look at creating additional metadata around the data that you care about. So digital signature is one of them, to be able to understand who generated the data and where it's coming from. But I think if you could augment that with another policy item, the policy item would be able to define what I refer to as an SLA, you know, service level agreement of what data is about. And if someone was going to use it, process it, and leverage that, they need to have certain level of trust in order for them to have access and be able to compute and generate additional, you know, additional content that can be appended to that. So it's become, in a way, a negotiation between the original data producer and the entity that is authorized to make change or modify that data based on a certain level of understanding of SLA. So the data owner may request that the middle box or whoever's processing the data needs to have this certain level of capabilities. And in this case, it's about security capabilities. You know, are they using trusted code? Where are they computing this? Where's this data is being processed, and so on and so forth. So if you could define that policy so that in a way, you're defining the runtime environment of how that data could be processed, and then additional content may be augmented to that.
Just one tiny comment on this. But the concept of SLAs, I think it's a kind of thinking that there is a limited number of parties doing processing. And I think for the vision for the future, look, everybody's carrying like a cell phone that is like way more capable than whatever 20 years old computer. So everybody technically can do the processing. This processing is proliferation like everywhere. And how to do this SLAs, like if everybody can do the processing.
So I think SLA, I'm using SLA kind of loosely here. SLA in this way, in how referring to it, is really a technical contract. It's a policy. It's a binary policy that you wrap around it. It's not a a written down kind of thing that you're talking about. So as long as the computing device that's going to process this data has this kind of characteristic, it has a hardware root of trust. The firmware is signed. The runtime environment is protected. No one has loaded that device with other things. It has certain level of security, maybe multi-factor authentication on it. I mean, all kind of other stuff. May have a crypto engine that's on there.
But you also need a way to verify that the platform meets those constraints,
Yep.
right? I would just, one other thing about, I really like the point about immutability coming from long time ago formal methods background, it's well known that it makes it much easier to reason about a system if if once a variable takes on a value, it doesn't change, right? I think Van calls it referential transparency.
Good.
Okay, Kathy Nichols from Polaire, and I kind of wanted to say something about the provenance issue that Christian brought up. And I'm in the early stages of looking at a measurement architecture using NDN. And part of that is thinking about the idea that you do want to keep track of who's asked for measurements and whether they were done. And that leads you to not to think about using things at the sync protocol level and the pub sub level. And I'm hoping that this is the way to do it. I'm still in the early stages and looking for more feedback, but this is obviously just a solution at one level to one problem. But the idea is that if everything has been published, then if you archive those collections, you can keep as much of a record as you want. So I guess I'm kind of encouraging people to think about that sync layer that we're going to put on top of the interest data structure, and what do we want that to do for us? Because I really think that was important to me looking at this issue, and I think that might be helpful in some of these other problems. So I'm glad that people are working in that area, but I'm going to be a user of that work.
Thank you for those comments. I just want to kind of one piece of warning. We cannot really store all the data that's been produced forever, because especially when we have like a vehicle, aircraft producing 3 gigabytes of data per second.
5.
Okay, even whatever. Those can be produced, potentially stored for a reasonably short period of time, then kind of summarized in some form, processed, and then the result of the processing stored for future reference, but not just the raw data. And we're going to have way more data. I mean, we already have a lot of data, but we'll have even more with all these IoT items.
All right, so in some of the presentations and in some of the papers I've read, they talked about constrained devices, but they never said what exactly a constrained device means. So I was wondering if you could shed some light on that. And there's a couple reasons I ask. One, I'm on the lightweight crypto project here, so we're fairly specific about there's no like solid line, but it's kind of horseshoes and hand grenades type constraint. But if you have some kind of protocol where you're generating something randomly, you're going to need to have a secure random bit generator. You're going to have an entropy source, and you're going to have enough entropy. So depending how fast you read from the entropy pool versus your consumption rate versus your entropy production rate, that's going to make a difference. If you don't have enough entropy and you're generating random numbers, then an attacker is going to be able to leverage that. Just the ability to get out-of-band trust information. But if you had like a secure connection, like, I don't know, even something as simple as like when I configure my children's toys and I connect to my phone through the audio port, just something basic like that where you can transfer data on a physical connection. Is that something that people are thinking about and concerned about? Would it be acceptable? And also the device lifetime and crypto agility. So if we talk about hard coding keys especially, then we have to know what the lifetime of that device is going to be. How many messages it's going to produce in its lifetime is actually more important than the lifetime in some cases. And if that key is shared with other devices, because the more data you send depending on the cryptography schemes that you're using, with every message that you send, you're actually reducing the security a little bit. So when you reach like a critical mass on that, the security goes away. So just as far as the constrained devices go, have these things been discussed, thought of, addressed?
No, go ahead.
I can answer some of these questions. So for the type of the constrained devices, we have kind of one target that we have is something like a 32-bit ARM with 48 megahertz, 32 kilobytes of RAM, and like a very small amount of additional flash memory. So that's not good source. There's not good source for entropy. So there is a lot of limitations for those devices. That's a kind of one thing that we're working as part of the NDN Riot project. Then as the presentation that was this Operant Solar project company that is working. So they they also kind of using the constrained devices, but those kind of about multiplied by 4. Plus, they also have additional capacity. So that's respect to what type of the constrained devices. I'll answer the last question and then the second question. So for the lifetime of the keys, it really depends on the constrained device. If we're talking about a device that costs half a cent and operates for like a year and like deployed somewhere lost in space, then it's okay to have just a lifetime because you can buy like hundreds of them more and just configure. And I think this is the model for the constrained devices processing for the future. Maybe there's a.
Protecting for long either.
That's true. Like temperature measurement,
Yeah.
like at this point of time, not worth any time in the future. And for the second question is what kind of channels for the bootstrapping. So what has been presented is just one kind of, just attempt to create a showcase kind of simple environment. But when we kind of thinking of what kind of channels can exist for the bootstrapping, we kind of have a few kind of crazy ideas. One is using some form of audio channel, lightning, physical tapping, like snapping with a phone, and kind of we're trying to come up with some innovative things, but it really depends on the actual device. Like, is it even physically big enough to do anything? If it's big, like, can it be pressed or like, have some capability? If we, hopefully, like in the future, we have extremely cheap small devices that have some physical response, and with that physical response, we definitely can have something out of band.
Do you want to add more? I mean, especially given the discussion about how do you define constrained devices? Yeah.
So from my perspective, I mean, there's a it's a gamut, isn't it? It goes from really cheap couple of cents devices all the way up to something that goes into a manufacturing arms. I mean, so the requirements should be flexible enough to kind of accommodate all that. Because at the end of the day, it's about a business decision that a lot of these manufacturers are making in order to get these capabilities in. But I fully agree with Gary about the need for us, if we are dependent on cryptography to provide a certain set of capabilities and characteristics, and if foundationally the core pieces like the RNG and so on are not at the same class of level assurance that we expect, then there's fundamentally a lot of other issues that we'll have. So.
Yep.
So
And just for our own definitions of constrained, we have things like the amount of time it takes to process, or the amount of memory it takes, or energy, and you kind of move along a triangle. You don't actually, there's no one definition of constraint. So I was wondering just kind of what subsets that's, but it sounds like it's application specific, which is the same thing that we have, so.
I could provide some historical perspectives, and we were discussing this over the lunch. It was when I started doing my PhD, we used to talk about wireless sensor networks, and the discussion we used to have was, oh, you have an 8-bit RISC microcontroller, a few kilobytes of RAM, you hardly have any storage. What can you do with it, right? Now that was the lowest that you can go. I mean, you had RFIDs, but let's not talk about those passive RFIDs and all those things. Now, if you talk about IoT devices, we are not talking about an 8-bit RISC microcontroller very often, right? So we have actually moved the bar a little further. So when you introduce IoT devices, for most people, the thought that comes into the mind, oh, a Raspberry Pi. That's a very, very capable computing device. What? Yeah. Yes, exactly. But That's true for communities that have been working on it for a while. But if you ask a general audience, they're like, yeah, Raspberry Pi, I can't do much with it. It's a constrained device. So the distinction I'm trying to make is what we talk about as constrained today. 5 years down the lane, you're probably not going to even see that device, and it's not going to be constrained. But really, the question we should be asking is, how do you manage legacy devices? Because that is where we want to be able to deploy our protocols, if at all we're trying to look at security. And that's a hard challenge because of the administrative dimension, because of the policy dimension, because of all the other things. But again, I don't want to hog all the limelight.
I can just piggyback on, you said like in 5 years we're not going to see those devices. And actually, we will see all those devices because they're hidden somewhere in deployment. And that I mean, it's already a problem, and it will be a bigger problem as we go forward.
Yeah, can I just add to that? So people are still using SSL, and they shouldn't be, given the powerful computers of today. They should have updated to, well, now we're on TLS 1.3, which is 4 versions past, well, yeah, 1.0, 1.1, 1.2, yes. So we're 4 versions past, and there's still people using it. So I don't see that problem is going to go away, especially with if we're talking about devices that might not even have the update capability of current systems or our more powerful desktop systems.
Anecdote I can mention this UCLA building system. They're still using modem line, which is not even 36 K. It's like something like lower than that. 1400. So they have, they have modern links to some buildings, and for some of them, like whatever, I don't know, from 70s, I guess.
Anybody else on the panel wants to comment about that?
So I guess, I mean, as follow up to what Carrie kind of brought up, I being new to the NDN kind of community and understanding about this technology, have you guys defined, in order to achieve the characteristic and property that you're delivering with the stack that you're providing, what are some of the dependency that one needs to have in place in order to meet the security level protection that you are providing, like digital signature and so on and so forth? What are the expectations for the digital signature to work in such a way that it provides that kind of integrity to it, Because going back to if you don't have these foundational pieces in place, then the composition of those functions is not going to give you the outcome that you want to achieve at the end of the day.
I think that also kind of has to go into the discussion of the application, right? Yeah. So, for instance, if I'm just sending the temperature reading every minute, I can, certify and sign the heck out of it. But if I'm sending a video feed which is 4K, maybe 6K down the lane, you have bigger problems because I can't sign every single frame that I generate, or I could, but it's going to be very difficult to validate it. But I'll stop. Do we have any? Yeah, please go ahead.
I do have one question. You just mentioned legacy devices and support of legacy devices. I guess this applies even in design, security, in every aspect. When you're designing something that the new devices support, would you account for the legacy devices that much, or would you just create a tunnel or an adapter in between? Which approach would you take mostly?
That's a good question. Anybody from the panel wants to answer that question?
Sure. Go ahead.
So I've always been on the mindset that because NDN is such a paradigm shift, for you to be able to introduce it to new environments, you have to provide that ability to do legacy support. So when you mention tunnel, that's sort of what I usually have in mind, is that you have to be able to provide some functionality that says we're not going to shut down everything and move on to a completely new completely new paradigm. We will basically work as is. We're just going to support what we have, but eventually there's a transition path. We start with utilizing the NDN functionality by things like tunnels and things like that, but eventually move on to a green all NDN design.
Yeah, and I think on one of my slides, I think I mentioned about this notion of gateway devices that will allow you to kind of bridge between what I call legacy environment with the more modern stack. So I believe that during deployment, you're always going to face that, going from brownfield to and moving out, because you have certain capabilities that you're providing, certain level of services that you have deployed across your organization or in your business. you want to still take advantage of some of that. You just can't turn everything off and migrate instantaneously. So I think there's always this notion of what going back to the discussion of the edge device can actually provide that kind of bridge capabilities at the link layer kind of level, I think of it, to kind of bridge the old traditional kind of IP way of doing things with the new kind of modern NDN way. So.
Sure, you had a comment?
Given all these discussions about the legacy LT devices or otherwise, the old version of SSL, I do see there's actually commonalities here. I think it's really about the protocol design, which is kind of orthogonal or independent from NDN. In protocol design, there's always this philosophy called the soft state. You should not have any so-called hard state. You should keep refreshing. And I think that, to me, is a fundamental approach to address the legacy old version problem. Either a device is totally died so that it cannot do damage. Otherwise, if it's alive, the architecture, the protocol must have automatic update functions. That is the only way, as I can see, to address this legacy problem. You cannot depend on humans. You cannot depend on other things. So all the devices, all the protocols, if they can talk at all, they must support automatic updates. This is one lesson. People ask what lesson we have learned from running NDN playing with NDN, I should say, for so many years. One thing is that don't expect the programmers to do the right thing. Well, many people do, but there are always some who do not. Like NDN has a security design to say all the data need to be signed. When people develop the applications, the very first shortcut they will do is get rid of this signing and verification. Put some garbage, you don't verify the perfect fine. Hey, your application runs. So that's how all this automating security came in, because we realized we cannot depend on people to do it. I think for this potential legacy things, for the existing legacies, I don't know what to do with them. But for the future ones, we have to prevent them.
Can I offer a controversial point? Maybe controversial. For IoT devices, the small one, maybe we should have a policy that they have to have a death cycle.
End of life.
Like 5 years and that device goes offline. That's it.
You can have policies. The question is the execution. And you cannot depend on the execution.
Or you could use
have to enforce it.
the Apple Google model where you send in updates which are so expensive to run that the device never functions anymore. So then they'll update it anyways.
I was just going to say this argument, this idea that you brought. I'm sure all the vendors will be very happy with that.
Yeah. Well, we need to educate everybody so they realize it's actually a feature. It's actually a positive thing, right? That the things, you got to replace it. I would have a hard time, it takes me a while to swallow that, but I think it really is.
So I think philosophically, I think we in the software kind of industry understand that there's this notion of, you deprecate code, you move on to the next version, move on to better things. But in the physical world, when you have a device, you have your refrigerator, you have your smart TV, telling someone that TV is no longer patchable, upgradable, blah, blah, while the LCD is still good and you still get good pictures and the sound is perfect, how are you going to deprecate that? It's really tough, making those kind of decisions.
But really, maybe for something like that, you don't have to have it stop working. You just have to have it stop talking to the rest of the world.
Exactly.
Right? If it's completely isolated, it should be fine, right?
Yeah, so one of the research projects that we're working here at NIST is bringing that concept of providing that, again, at the edge kind of perspective, be able to do those kind of isolation of what we call legacy or end-of-life devices, so that they have a minimum set of capabilities. They can still provide that, like your TV is going to be your TV, but you maybe you no longer will be able to surf the web and be able to pull down, potentially malicious content, things like that. But as a core set of functionality, it'll provide those core set of functionality.
So basically, you can't watch Netflix anymore over the internet. You can still watch television, but you can't watch Netflix. So you'll go back to DVDs.
Yeah.
So I have to say that this notion of isolation is hard to swallow given what we're seeing today. I don't think there's anything isolated. Actually, we're pushing more towards everything connected. So I don't know if you can claim that that's a possibility.
Well,
Okay, one last question. Sure.
So yeah, this is Yao Qingliu from Clark's University. Actually, we talked about a lot about security, but I remember one panelist mentioned the privacy issues regarding the names. So I mean, I want to see some insights about how would you make sure the privacy is protected through names, but we're still able to do those NDN things.
Well, I can tell you that we're working on it. I don't know if I don't know if there's a solution yet because it's, as I said, it's a problem that we started having in a particular context, and we're trying to figure out how to deal with it. I don't think we have a solution yet. And it is a complicated issue because you have to use the names in order for you to be able to route the data and deliver it correctly. And it's not as simple as just you encrypt the name because it just, it introduces another problem because now you have key distribution that you have to deal with. And it's not as simple as let's hash the name because it just becomes something like a pseudonym, right? You could still use it to be able to do statistical analysis and understand, what is being requested and things like that. So it is a complex problem. I don't know if we have a solution for it yet, but it's something that is being worked on.
Thank you to the panel, and thanks everyone for listening in and your questions. We call it adjourned.